Okay, so in this next question we're asked to prove that the equation has at least one real root. So in order to do that, I'm going to use the intermediate value theorem. Basically, I know this function is continuous, so I'm going to be picking 2 points, and if I can find one point where f of x1 is negative, for example, and f of x2 is positive, then I can say at some point between x1 and x2 the graph crosses the x-axis, and that's where its root is. So I'm just going to start with the most simple number I can think of. I'm just going to do f of 0. So if I do f of 0, then that's going to give me cosine of 0 minus 0 cubed. And by the way, I'm sure there are many different ways that you could prove that this equation has one real root, but because we're in calculus and because this unit covers the intermediate value theorem, that's what I'm going to be using. So cosine of 0 is 1, and 0 cubed is 0, and 1 minus 0 is 1. So right there we have a positive number. And then if we do f of pi over 3, for example, we're going to have cosine of pi over 3 minus pi over 3 cubed. Now, cosine of pi over 3 is 1/2, and pi over 3 cubed, we can't really use a calculator, or at least in this class we're trying not to use a calculator, so I can just write that as pi cubed over 27. Now, if I just think about this, I know that pi is 3.14159 followed by an infinite string of numbers. So it's going to be greater than 27, because 3 cubed is 27, but we already know that pi is approximately equal to 3.14159, all the other numbers. So it's going to be greater than 27. So we're going to have a number greater than 27 over 27, which is going to give us a number larger than 1. So 1/2 minus a number larger than 1 is going to be a negative number. Now I think in this case it works out to negative 0.64 and then some other numbers, but we can see that it's a negative number. And now this is what I'm saying. So we know that this function is continuous, so we draw the graph somewhere between 0 and, if we mark out pi over 3 here, and it's going to be 1 at 0, and then it's going to be negative 0.64 at pi over 3. So I know that since this function is continuous, it's not going to do something like that. It's not going to break apart. I know that since these 2 points have to connect, there has to be a point where it crosses the x-axis. So that's how you would prove that one. In this next question, we're once again asked to prove that the equation has at least one real root. So again, we're going to use the intermediate value theorem. So again, I'm going to start with the simplest number I know, 0, and I'm going to plug in 0 wherever I see x. So I'm going to have 0 to the 5th minus 0 squared minus 4. Now 0 to the 5th is 0, and 0 squared is 0, which leaves us with 0 minus 4, which is negative 4. Now if I were to plug in something like 1, for example, I would still get a negative number, because I'd have 1 to the 5th, which is 1, minus 1 squared, which is 1, and 1 minus 1 would be 0, and I'd still have negative 4. So I'm going to plug in 2 instead of 1. So if I plug in 2 instead of 1, I'm going to have 2 to the 5th minus 2 squared minus 4. Now 2 to the 5th is 32, 2 squared is 4, and we'll have minus 4. 32 minus 4 is going to be 28, so we're going to have 28 minus 4, which is 24. And as you can see, once again, we have a continuous function, and we have a point where the y value would be negative and a point where the y value would be positive, meaning at some point between those 2 points it would have to cross the x-axis and giving us our real root. So that's how you do that one.